this. How is this for everyone? Good. Awesome. Yeah, thank you so much for the introduction. I'm really excited to speak here today. This is work that my group and associated groups across COG UK, UK HSA, and other groups internationally have performed over the course of the pandemic. So I'll go through the initial assessment of the establishment of the SARS-CoV-2 in the UK, then move on to the Alpha variant, then move on to the Delta variant, and then show some very recent work on the Omicron BA1 lineage in the UK. And I want to sort of speak a lot about how the context at which each of those variants have arrived in the UK have changed the patterns of transmission of them, but also how similar they may be and what that tells us about potential future variants of concern and what we do to prevent them to cause a large burden in the population. So just as a reminder, many of you on the call, I'm sure, are very well aware, since the autumn of 2020, we have really changed the landscape of how we have to think about this pandemic with the arrival or the emergence and detection of the Alpha variant in Kent and Greater London area in the UK. So what I'm showing here on the top panel is the frequency of different variants of concern. The orange one shows the Alpha variant, the blue one shows the Delta variant, the red one BA1 lineage, and the green one the BA2 lineage. And on the bottom panel, you see the numbers of cases, obviously with the caveat that a lot of the case reporting has changed, specifically sort of after the first wave, and then very, very recently, as you can see here, with some of the data points being a little bit up and down. Anyway, what you can see there really is that you have this massive invasion of the Alpha lineage or Alpha variant in the autumn, which was then rapidly displaced by Delta in April, May 2021 until December 2021, when Omicron BA1 lineage took over in the UK, which was then rapidly replaced again by another Omicron lineage here called BA2. And what you can also see on the bottom is that each of those were associated with a rise and uptick in cases. Specifically, the winter wave 2020-2021 caused a lot of fatalities in the UK, or deaths. And then we had sort of a relatively high incidence in the UK throughout the Delta wave in the summer of 2021. And then, of course, the recent massive wave of Omicron, and then now rising cases and hospitalizations in the UK caused by BA2. In that same period, we've also had the rollout of the vaccine, first dose here in light blue, second dose in dark blue, and then in darker bluish black color, the booster rollout with, as you can see here, sort of in that period, late November to mid-December, an acceleration of rollout of the booster in response to the emergence of the Omicron BA1 lineage in the UK then. So what throughout this pandemic we tried to do is define independently introduced transmission lineages to the UK to then try to reconstruct and understand the specific lineage dynamics and what they can tell us and how they can help us understand the epidemic or pandemic in England better at high resolution. And really it's trying to sort of move the genomic evolutionary analysis more closer to informing epidemiological models. So a lot of that was also trying to sort of build evidence, build parameters or statistical measurements of genome frequencies or their spread or importation patterns to then put this into epidemiological analyses later on. And this is obviously a research program that will take a lot longer to develop, but it's kind of an attempt to synthesize those who work more in epidemiology and those who work more in evolutionary biology or phylogenetics. One of the very interesting findings during this sort of exploration of genomes that we analyzed from the first wave, which were mainly created through this consortium of COG UK, was trying to understand the lineage size dynamics through time. So what you see here on the bottom panel C is like how many lineages, like the frequency of lineages at different sizes. So as you would expect for a pathogen like SARS-CoV-2 that is defined by super spreading, is that a lot of lineages die out relatively quickly once they have arrived in the UK. So therefore you see a lot of them, so 300 to 400 of them, just like a couple of lineages, a couple of isolates found for those specific lineages in the UK. And then you have a few that grow very, very large, and most of them obviously arriving at times when there were relatively little restrictions during this initial invasion phase, and those then starting to dominate the epidemic of the first wave in the UK. What this also helps us do when pairing this data together with travel data and incidence data from other countries during that first wave is to trying to disentangle the source locations of these transmission lineages. This wasn't necessarily possible just using phylogenetic inference frameworks because of the uneven sampling distribution of SARS-CoV-2 genomes, specifically during that period. So what we try to do is not make any assumptions of the underlying process of the invasion, but rather pair the information with how many cases or deaths were reported across the world to then reconstruct the sort of pressure of invasion onto the UK, and then match that to the dated introductions of the SARS-CoV-2 lineages in the UK. And many of you have seen this many times before, but just to go through is that in the beginning of the epidemic, there were only a very few introductions that then, really took off in the UK from China. It was then mainly dominated in the period of February by importations from northern Italy, which was also the place that had the highest incidence. And I think at that time, I think I tell this story many times, is you could not leave the house in Italy, but you can go from arriving in the UK straight to the pub and really infect others. So this was a time where there were almost no restrictions in place, non-pharmaceutical interventions in place in the UK. However, then the dynamics shifted. The epidemic in Europe was much larger than in Spain throughout the month of March, and the half-term holidays were taking place. So a lot of people were traveling to Spain and bringing back infections that could then spread onwards in the UK after people returning. And then, of course, we all know on March 23rd, the lockdown in the UK caused importations to be massively reduced, but also transmission at that point was really contained by transmission lineages that were self-sustained in the UK during that time. Now, the other thing we can take out of these large-scale genomic analyses is trying to understand in each given UTLA or LTLA in the UK how the heterogeneity in co-circulating transmission lineages. So why is this important? It's important because we try to understand, how many importations then within a given location actually are, how the epidemic in a given location is composed of multiple different lineages co-circulating at the same time. So, traditional models would potentially assume that there are a couple of early introductions, then they would dominate each location's epidemic. However, with these analyzing genetic data, we are able to look through time on how different transmission lineages within a given location are composing that particular epidemic. And you can see, of course, and this is expected, that places that have high connectivity, high population density, like Greater London area, are the ones who have the highest diversity of co-circulating lineages, and then more rural areas may have a couple of introductions that cause one or two transmission chains to be sustained, but those then also die out relatively quickly after non-pharmaceutical interventions come into place. Fast forward to October, November 2020, we had the detection and emergence of the alpha variant at that point called B.1.1.7, and this was really the first time that people realized, well, there may be some variants coming along that are potentially higher in transmissibility. So this was still defined by variants of much higher transmissibility, initially detected in the southeast of the UK in Kent, but then really quickly spread into the Greater London area, specifically sort of East London. And from there, rapidly expanded after lifting of lockdown restrictions in November 2020, end of November, early December, and then spread from there onwards across the entire country. It was really interesting because at the time, Alpha was spreading in lockdown conditions, and it was for a long time, I think, the question of like why is that happening and what could cause that. And later on, of course, we identified the generation time to be one of the factors contributing to the probability of between household transmission in that period in the area of southeast England. Now, very recently, there were some reports on like the actual emergence, the earliest genomes found that contained the mutations that were then defined as B117. And you can see on the bottom figure there, and this is a recent preprint from Verity Hill and the Rambos group, that B117 really during the lockdown period was spreading faster than the lineages that were previously circulating that were composed of multiple different transmission lineages. But this was then also a particular time and context within which B117 could spread, which was one where there were a lot of movements out of the Greater London area. Many of you will remember a large exodus out of the London area around Christmas time, right before Christmas time, the announcement of restrictions in the London area, and these photographs of people at the different train stations. And what we were interested in is trying to look at how these specific movement patterns during that time impacted the arrival times of B117 across UTLAs in the UK. And what you can see here on panel C on the bottom is that the movements out of Kent and Greater London well predicted the arrival times of B117 across UTLAs in the UK. Also, we know this now, we knew this before, London, of course, plays an incredibly important role in connecting the entire country and the big cities specifically. London, Birmingham, the Northwest, Manchester, Liverpool area is very well connected to the Greater London area. And that then led to really this invasion wave out of the Greater London area across the UK. And what this really allows us to do using continuous phylogeographic models is really reconstruct these virus movements between different areas. What you can see here on panel A and B is reconstructed location exchanges of B117 transmission chains ultimately between, and the earlier sequences being represented with blue, like darker blue, and then the more recent ones in yellow and lighter green. And you can really see sort of that massive outpouring of virus out of specific areas. And this is only possible really in the UK, given the very dense sampling scheme there. Now, this is of course like highly intensive. It took us quite a long time to actually produce these models, and is something that will maybe in the future be available in real time, but is still sort of lacking in its ability to really inform policy in this specific moment when decisions need to be made. And some of you on the call will remember this from our conversations when the Alpha variant was emerging. However, we can use a lot of other information, specifically in the UK, collected through the Office of National Statistics, the prevalence surveys, to try to build sort of estimates of potential virus movements between areas, so that you can see on panel C here, where you can see an estimate from continuous phylogeographic analyses, which is sort of we would say, given the sampling, kind of a gold standard in the UK. But then you can also get similar estimates from using mobility data in combination with the prevalence surveys in the Greater London area to reconstruct kind of how many movements of virus you would have expected there. Now, panel D is really interesting because that shows you kind of the numbers of independent importations at the LTLA level across England. And there you can really see that the boroughs in London, of course, had a lot of importations because there's frequent exchange between them, but also you have areas, for example, Oxfordshire or the Northwest, where you have frequent introductions. And then the question really becomes, how important are these importations to also driving up growth rates at the invasion phase of a new VOC. So that's what we try to do. We try to sort of build a model in which we can try to estimate the difference in growth rate between B117 and other at that point circulating lineages, and how well we can predict that difference by using the estimates of the independent importations into those places in each given week. And specifically for the period of invasion, just somewhere between mid to late November through mid-December, these mobility patterns and virus importations out of the Greater London area were very well predictive of, or correlated, at least in this case, of the growth rate difference between B117 and other co-circulating lineages. So, and this is really a similar trend than what we have observed very early on in the epidemic, or at least pandemic in China at the time in January, February of 2020, when we saw that growth rates across provinces in China were very well correlated with the movements and cases out of Wuhan province, which informed our understanding of the importance of multiple seedings potentially in driving up growth rates early on in the invasion time of a new VOC, or in this case a new disease in SARS-CoV-2 out of Wuhan, and how we can incorporate such information better going forward in epidemiological models. Can someone tell me the time? I don't know how much time I have left.
Yeah, you've got about 5 minutes left. 5
minutes left. Okay, so fast forward to the Delta variant invasion, which was initially sequenced in the year 2020, but then for a relatively long period, didn't really observe a large increase in cases there until sort of March, February 2021, when it caused this massive numbers of cases in India, and then its rapid expansion outwards from there into the world. And in the UK, we're specifically looking here in the UK, we were interested in the impact of previous immunity, vaccination, but also relaxation of NPIs, and you'll remember this, during that period in England. At that point, the UK Health Security Agency and many members of different teams in SPI-M and other modeling groups in the UK had built a framework for analyzing the potential difference in secondary attack rates by linking genomic data to contact tracing data, which became kind of the gold standard of understanding the growth rate difference between a new VOC arriving and, in this case, Alpha, which was then prominent in the UK. So we almost felt like this was kind of taking care of estimating these differences through time, because there was such a well-designed framework at that point where you could link genetic data to contact tracing and household studies to estimate these differences, and that continues to be active now when BA1 and BA2 came into the UK. Now, at the time, Delta arrived in the northwest of England and was spreading there locally for quite a long time. There were surge testing programs at the time active in Bolton and other regions, but just after a while, it just quickly invaded the entire country, and specifically lineage AY4, which is shown here at the top panel in red at the bottom, which has a TMRCA of somewhere around late March, and then really caused many infections in the UK starting sort of late April, early May. Now, what really changed was then the question, how can we describe that in the UK during that period? So what you can see here is different, in the yellow is numbers of cases reported in India. The red line is mobility between states in India, which kind of has a big uptick starting in late or early February where movements really increased by about 15 to 20% then, and then a rapid decline in movement in India following restrictions, but also like such a high number of cases that people reduced or at least adjusted their behavior. Now, what happened in the UK was a bit different. So we had the massive lockdown, of course, in 2020, and then sort of a slow recovery of numbers of cases, then a quick sort of drop again during the Alpha variant in early 2021 before it started climbing. And that's really, we found crucial, because from then onwards, we had sort of, continuous relaxation, but also people were vaccinated, and there was a lot more activity in the country in terms of between UTLA mobility. So you can see that dark blue line sort of coming back up, and I'm sorry for that not to be so visible, but you can see that with Mobility UK indicated there. So we really asked the question at the time then, how did that potentially influence then the rapid invasion of these different independently introduced transmission engines in the UK? And what you can see here in panel B, and I'll stop after that, is really that relaxation process, the yellow line, increase in mobility through time, really going back up from about 30% of regular mobility up to 0.70% of mobility compared to pre-pandemic, the pre-pandemic period. And then really after the stage D relaxation of restrictions, a rapid increase in the geographic expansion of the Delta variant in England. So it's really, we believe, when we build a statistical model on top of that, one of the important factors that the local restrictions in place were the ones mostly responsible for the rapid expansion of the Delta variant. And again, we see that repeated for Omicron, where locally we are almost at the same levels of mobility than we were before at the arrival of Omicron, where the importations were actually not so relevant for driving the epidemic anymore. But I'll stop here, just go to the last slide. And I'm sorry I couldn't talk about our most recent Omicron work, but we'll do that some other time. You can always send a message and ask questions if you have them.
Thank you very much. That's like that is exactly what, with the kind of thing I was very interested in seeing at this, showing how these methods could be used in real time. We do have a couple of questions in the chat. So the first one is, was there a difference in the symptom profiles at presentation across locations in the UK in this data set? So I don't know which of the comparisons that question relates to. Maybe you could add to the chat. So, but in general, was there obviously any kind of difference in symptom profiles across space? Do you know?
So we didn't in this data set look at that. So this is not a data set that would include much information about symptoms. And there'll be other people who look more at the changes of, presentation of disease across different age groups, across different socioeconomic groups, for people that see care in different ways and so forth. So I would say it's not something that we specifically looked at. I think it's really interesting in the context of the emergence of specifically the alpha VOC, because there we, at least when we looked at the data at the time, the generation time seemed to be very, very quite different. And then it's a question kind of, like how does that also then influence when people show symptoms, how they show symptoms, when an infectious period is highest, and how that can affect the disease dynamics. And I think we learned a lot, but Robin, Thompson, Julia, who I think is here, they have looked at that in more detail than I have.
So the next question is, by UK, do you mean England? Because there are potentially important differences in the timing of interventions between England and Scotland, which might be visible.
Yeah, absolutely. Our initial analysis for the initial SARS-CoV-2 wave in March 2020 was across the UK. So that includes Scotland and Northern Ireland. now and Wales. And for the subsequent analyses, however, we only included England. In terms of the interventions that were put in place, I think for the first wave, if I remember correctly, those were mostly done on March 23rd, I believe, for all countries. And in the subsequent analyses, we used England because, as said, there was heterogeneity in the application of non-pharmaceutical interventions. So to that, it differed kind of between the analyses. It also became increasingly harder to link data between the different nations, and therefore we focused mostly on England in the analysis of Alpha, Delta, and then Omicron now.
Thank you. And then if I can ask a question quickly.
Yeah.
Very early on in your slide where you had the distribution of lineage sizes, it looked very exponential. Is there a theoretical distribution that should follow if you have multiple importations of a virus with the same characteristics?
Yeah, really good question. I think it would depend on the specific context and the specific disease or infection, what kind of distribution that should follow. I don't necessarily, like a lot of the times in epidemiological models, we make some sort of assumption how that distribution should look like. Now, my hope would be, could we use this type of information to define these distributions when trying to analyze, for example, specific offspring distributions when having new VOC surviving in the country, and use sort of previous estimated distributions from previous variants to see how they can inform sort of, more predictive models ultimately of, let's say, geographic spread of a new VOC. So that's kind of, I think, one of the interesting things here is that we can. It was primarily, like as it usually is a reconstruction, and you look in the past, like kind of what happened. It's more an inference framework there, but how can we now use some of this information as we are sort of moving into trying to understand, future distributions of these of new variants, for example, or when a new one emerges somewhere, what is our expectation how they may unfold in the country of arrival? So very good question. I think there's a lot more work to be done there.
Thank you very much. And thank you very much for the great talk. I'm afraid we've come to time. So